So here's some Boyles Law practice. So we're using Boyles Law, our formula right here, pressure and volume, and we're going to do some Boyles Law practice. So our first one right here, clowns normally use tanks of helium to inflate balloons at parties. Again, these are ones you should do on your own first and then come back and check your work. So first, let's identify everything we've got going on here. We have 850 millimeters of mercury. So that is going to be our pressure one, our P1. And then we have V1, volume of 15 liters, V1. And then our V2 is a volume of 10 liters right there. So first thing we'll do we want millimeters of mercury? No, we want ATM. So we have to go back and convert right here. If we remember, 1 ATM equals 760 millimeters of mercury. So what you can do, skip ahead one, what you can do is just divide this by 760. So 850 divided by 760. So that's going to be 1.1 ATM is going to be our pressure one. So 1.1 ATM, I just did that by dividing 850 by 760. So 1.1 ATM. And multiply that by our volume one, which is 15 liters. And we're going to set that equal to, we don't know our pressure 2, and we know our volume 2 is 10 liters. And so what that's going to get us, 15 multiplied by 1.1 is 16.5. We're going to set that equal to 10x. And then we just divide both sides by 10. So you just do this right here. Divide by 10 and divide by 10 to get x by itself. And 16.5 divided by 10. Our answer is going to be 1.65 ATM. And it's going to be an ATM since we converted this to atmosphere. So you want to make sure you keep it in atmosphere. So that is going to be our answer. That is our new pressure right there. When the clown transfers his helium to a smaller tank, the pressure will increase from 1.1 atmospheres to 1.65 atmospheres. So again, volume shrinking, pressure increasing. All right, let's look at our second example here. We have an old man with an oxygen tank, and his oxygen tank is about 12 liters. So that's going to be our volume 1. It's always set to have a pressure of 150 kilopascals right there. That's going to be our pressure 1. Pressure 1. He decides to upgrade to a new tank with a pressure of 2.2 atmospheres. What is the volume of his new tank? So this is our pressure 2. What's the first thing we should do, or you should have done, is convert 150 kilopascals into atmospheres. When we do that, if we go back, skip one too far. If we go back right here, you do the 1 atmosphere is 101.325 kilopascals. 101.325. Man, I'm skipping all over the place. So all you do here is to get that answer, you do 150.12. Let's type this out for you. 150.12 kilopascals divided by 101.325. Because that is our ratio, and you end up 101.325, and you end up with 1.48 atmospheres as our pressure 1. So let's set up our ratio here. Remember our formula, P1, V1. So our pressure 1 is 1.48 ATM. That's what we just solved for by converting from kilopascals. 1.48 ATM multiplied by volume 1, which is 12. Set that equal to our volume, or our pressure 2, which is 2.2 ATM. We didn't need to convert that. It's already an ATM. And then x. So 1.48 times 12 multiplied by 12 is 17.8. And that is equal to 2.2x. And then we just divide both sides by 2.2. And our answer is going to end up being, after dividing by 2.2, x equals 8.08, and it's a new volume, so we're measuring it in liters. So our old man here with his new tank of oxygen, it is now 8.08 liters, meaning its volume decreased so that the pressure could increase. The pressure went from 1.48 to 2.2. The volume went from 12 to 8.08. Let's do 2 more quick practice problems with Boyles Law. A balloon contains 7.2 liters of helium. The pressure is reduced to 2 atmospheres, and the balloon expands to occupy a volume of 25.1 liters. What was the initial pressure? That's important. What was the initial pressure? Initial pressure right there exerted on the balloon. Because we're searching for the initial pressure, initial means the first, so we don't know our P1. We do know our P2 right here. This is our V2, and this is our V1. Now the reason our P1 is down here is because it's asking what was the initial pressure, which means the first pressure. So this will be matched up with that. We don't have to do any conversions. It's already in atmospheres and liters. So we'll do P1, which is 7.2, or sorry, P1, which we don't know, times V1, which is 7.2. We'll set that equal to 2.00 atm, our P2, and 25.1. So you end up with 7.2 x being set equal to 50.2, and then you just divide both sides, 50.2, divide both sides by 7.2, divided by 7.2, and you end up with your x, or your initial pressure, equaling 6.97 atm. So that was the initial pressure of this balloon, was 6.97 atm, atmospheres. And let's check to see if we're right. The balloon was 7.2 liters and the pressure was 6.97. When the pressure decreased, the volume increased. So that goes with our same trend of one increasing the other as the other decreases. Okay, here we go. There's going to be 2 conversions we have to do on this last one. First, you'll see we have 352 milliliters of chlorine. That's going to be our V1. It's the first volume we see. Under a pressure of 680 millimeters mercury. So that's going to be our P1 right there. P1. Now they are under a pressure of 680. Now they are placed into a container under a pressure of 1210. So that's going to be our P2. And what is the volume of the new container in liters? So there are several conversions we need to do. First, we have to convert this into liters. So we would do 352 divided by 1,000. That's going to equal 0.352 liters. So that is going to be our V1. Put that in parentheses, V1. All right, then we have to do 680 divided by 760 to convert millimeters of mercury into atmospheres. Always divide by 760. So 680 divided by 760, that's going to be 0.89 atmospheres, and that's going to be P1. Then, because we're given millimeters mercury again, we have to do 1210 divided by 760 once again. So that's going to equal 1210 divided by 760. That's going to equal 1.59 atm. That's going to be P2. Now we just have to put it all together. So we have P1, which is 0.89. We have V1, which is 0.352. We'll set that equal to P2, which is 1.59, and V2, which we don't know. We are solving for V2 because you see our question right here is asking for the volume. So that is what we are solving for. Remember, I just want to go back here. I divided by 760 right here, because if you remember, 1 atm equals 760 millimeters mercury, so you have to divide by 760. So that is why I divided by 760 on both of these, because we were dealing with millimeters of mercury and we needed to convert to atmospheres. So just quick recap on that. Okay, let's do 0.89 multiplied by 0.352. It's going to give us 0.31 on one side of our equation here. So 0.31, that's going to be set equal to 1.59x. Divide both sides by 1.59, so 0.31 divided by 1.59. Our new volume, because we are solving for volume, is going to be 0.1. We're actually just going to round to 0.20 liters is going to be our new volume right there, 0.20 liters. Let's see if that works out correctly. We start off with 0.352 liters. That's a bigger number. And then our pressure increased from 0.89 to 1.59, so therefore our volume needed to decrease, and our volume did decrease, so we got the correct answer. That is Boyles Law. More wonderful gas law practice. Best day ever. Farewell.